So good afternoon, everybody. Today I want to guide you through a technology solution that provides one of the solutions to an issue that India is having. So I will guide you through our company, which is called Clariant. I'll guide you through our technology, which is called sunliquid. And I will show you how can this technology provide the solution I was talking about by converting agricultural residues into lignocellulosic ethanol, which would then enable India to be able to sustain with local resources, so to reduce the import of gasoline, provide additional revenue stream to Indian farmers, and last but not least, also reduce the big pollution issue that India is having. So let me start with our company. Clariant is a Swiss-based company. We're a global company, so a global footprint. I don't need to go through all these numbers, maybe some high levels. 6 billion Swiss francs sales. We are present in a lot of countries, 52. Of course, we have a big footprint here in India as well. I will go through that detail later. A little more than 18,000 people. And one of the strategic focuses is certainly into sustainability. Sustainability also for the reason that this is why we wanted to create a solution that would enable us to use an abundant source of feedstock, as I said before, agricultural residues, to provide a highly sustainable solution to the market. Not only that, but also our product portfolio is very much focused into sustainability. We're part of the main sustainability index associations in the world. And even though maybe some of you have not heard about our company, I'm sure that you have all either used or are aware of some of the products that we produce. So let me just test it. How many of you own a Ferrari? Okay, then I have to think of something else. How many of you have drank Coca-Cola? Okay, so in these two cases, we, for instance, produce the color, the red color, both of the Ferrari and Coca-Cola. So the pigments are produced from Clariant. This is just to mention, of course, one of the products. But the focus of today's discussion, as I said, is on sunliquid. So back in 2006, we decided to bring in a green footprint within our chemical specialties. And we said, okay, let's look for the abundant feedstock, which is agricultural residues, and let's create an internal solution, an internal technology that can convert these. And let me guide you through the main steps of this technology process. So you see here a feedstock. We pre-treat the biomass. This is a chemical-free, completely chemical-free pretreatment. It's basically using temperature and steam. So we pre-process the biomass. We use a small portion of the biomass as an elementary source, as a carbon source to the enzymes. So this is one of the first differentiators from other competitive technologies. This is a completely integrated enzyme production, meaning that you're not dependent from third-party providers, meaning also that these enzymes use this raw material, so the residues, to produce more enzymes and to produce also the microorganisms that enable to cut down the fibers of the biomass. So then these fibers need to be converted from a fiber into a sugar. In this case, that's the hydrolysis step. So we produce C5 and C6 sugars in their mixed sugars. Here we go into the first main product or byproduct, which is lignin. Lignin is a beautiful biomass. It can be nicely burnt. That provides the energy needs to the system. So you can see this as a nice closed loop. Of course, it can also be higher value-added end users. We go down from the hydrolysis to the fermentation with a complete C5-C6 conversion to ethanol. Thanks again to the microorganisms that are produced in the site. And then you have the well-known distillation of the final product to reach an ethanol, which is great use that can, well, in the case of India, for instance, can be used into transportation into cars. So main focus of the technology, as I said, we have a chemical-free pretreatment, complete enzyme and microorganism process integrated solution that this enables you to cut down drastically on production costs. And then, of course, we have the organisms that convert these sugars into ethanol. Where has this been developed? It's been developed in Germany. You have a picture up there where the new building where the group biotechnology, that's where I'm also sitting. I'm based in Munich. So we have our main R&D center. We have our pilot plant that's been up and running since 2009. So this is where we test also different feedstocks. We also started up our pre-commercial plant in Germany, close to Munich. We've been processing different type of agricultural residues since 2012. This has a 1,000 tons per year ethanol capacity. Main feedstocks that have been validated are wheat straw, barley straw, bagasse, corn stover. Of course, the next step is to go commercial. So that's what we did end of last year. We announced our own project. So you see a flag bottom left. That's the Romanian flag. So Clariant decided to build its own 50,000 tons lignocellulosic ethanol facility. We're currently completing detailed engineering, and the plant will be up and running in 2020. This is a completely greenfield plant. Our core business principle is to license this technology, so not to become a big biofuel player. So we sold our first license to another European player, to a biofuel player. They Enzyme in this case. They produce both ethanol and biodiesel in Slovakia. So this is another 50,000 tons per year ethanol facility, which will be integrated into the existing first generation plant. It's not been easy. Some of you might be aware of other competitors that have been having a lot of headaches in building up these facilities and making them work and reaching certain conversion yields. We also had a lot of issues, a lot of problems. But the difference is that we were able to assess these problems and find solutions. And this was also thanks to the fact that we're working at a pre-commercial scale size, which enables us to, for instance, use the process-integrated enzyme production. Because producing enzymes and microorganisms is a very costly element. So this was one of the boxes that were ticked. Biomass transportation in the facility is something quite new. So this was also creating, for instance, abrasion and clogging problems. We also find solutions here. Keep in mind that one of the other key aspects was that we said we should not develop any proprietary key equipment. We want to use known and available mature equipment from the market, and we should adapt to that equipment. When I say adapt, means that our software or the way we process it needs to be adapted to the system and to the available equipment. So no custom developed equipment is being used in our facility. So you will always find equipment that comes from the ethanol business, from the pulp and paper business, from the industry business in general. And I would say, last but not least, is that sometimes these providers do take technology solutions or process steps from different sectors or from different providers. We built up and we decided to develop this in-house from the very biomass pre-processing all the way down to the ethanol fermentation in one full step. So all these together enabled us to find solutions to problems and be ready to upscale it to commercial scale. You not only need to provide or build up a commercial scale, you also need to show the market that the final product can be utilized. This is what we've been doing already. You see a picture of Mercedes-Benz class cars. These are standard engine ethanol cars. So what we did is we said, okay, let's use 20% of our ethanol product that we produce in Germany from that pilot into standard engines. Let's run this fleet. These cars were running around in Germany. Let's test the environmental profile of the emissions and engine performance, and we did this with extremely positive results. This also shows that current ethanol engines, gasoline engines can run easily without any modifications into an E20 blend. In Germany and other EU countries, you already have E10. We need to go a step further. The same step that India is taking to go into E10. Another application is to use, in this case, it's even a higher blend. So 95% sunliquid ethanol was used in this Scania trucks with a 5% catalyst that Clariant produced in Brazil. So what we did here is we imported bagasse. It's another residue, most abundant residue in India as well. We imported bagasse from Brazil. We converted it into ethanol. We shipped it back in Suzano, which is near São Paulo, Brazil, and we used it in our trucks. Same concept. Let's look into the efficiency of the engines, and also here, extremely positive results. So how can this experience be used, and why are we present in India? Well, this technology works where there's abundant feedstock, where there's legislation in place, and India has both of these. So Ministry of Petroleum and Natural Gas mandated to use similar technologies in order to implement an E10 by 2022. They not only said that, but they said, okay, we want to set up 12 of similar technology plants in India using locally sourced feedstocks, so no import of feedstocks, and also they requested ethanol to be used in India. They support this by providing CapEx incentives, which is extremely important. They also support by saying we will guarantee the offtake, so we will buy the final product for a certain number of years. They enable to do this by stating, okay, the oil majors need to come out to the market with tenders. So these tenders have already started. We are in the process of participating to these tenders, and projects are being awarded for the construction of these plants. We see a big potential. The 12 plants, we see that as only the first phase. I mean, it needs to demonstrate that things work and work well, but the potential is a lot bigger than that. So there's studies that show that there's a huge surplus on a yearly basis of agricultural residues in India. If those were to be converted with similar technologies, with similar yields into ethanol, then you could reach up to 28 million tons of biofuel, only ethanol, for the Indian market. So you see that this is one of the reasons why Clariant decided to be in India, and we see the Indian market as a strategic outlet for such a technology. How can we then support this? How can we support investors, Indian investors, with our footprint, with our local footprint? So these are some of the main advantages. Well, first of all, we have to show that we worked and we did our homework on the technology. So yes, we have more than 5 years performance runs on different feedstocks. I mentioned before, this has been done in Germany on multiple feedstocks. We are now in the process of not only converting bagasse, which we already did, which is the most abundant feedstock in India, but also going into other feedstocks such as rice straw and cotton stalks. It's a highly efficient process design. So we are able to work on a neutral pretreatment. We are also low in water consumption, and the footprint is quite small. You need to have solutions on the use of byproducts. I mentioned lignin, which is the main one for energy production. Vinasse can be brought back on the field as a fertilizer to the farmers. It's commercially attractive. One of the main factors is integrated enzyme production. This lowers down the production cost, so you can be competitive on an NPV base. We do have experience, a lot of experience in tendering processes. Other oil majors in other countries, not only India, are also tendering such projects. We can scale down or up our standard process size. I mentioned 50,000 in Europe. We're ready to deploy 25,000 tons ethanol, which is the scale be requested here. We are not an engineering firm, but we are flexible to work with local engineering firms, local equipment providers. This is certainly a plus. And last but not least, we have a dedicated team, not only international, but also an Indian team with 8 sales offices and 10 sites. I know that I'm running out of time, so I'll be quick. This is the last slide. What we offer is an integrated package. So I said we're licensing the technology. So we are providing the engineering package for you to license. We're also providing what we call starting cultures that enable you to process integrated enzymes and microorganisms in your facility. We provide training, we provide service. You can bring your own feedstock to Germany. We test it, we convert it, you bring your own engineers, you see the process, and then we base our process guarantees based on that. Thank you very much.